We shall now try to understand a concept called as pass by value, which is usually discussed when we talk about user defined functions. In order to understand this concept of pass by value, let us first try to take a look at a program, see how that program works, and then enhance our understanding about pass by value. So what this particular program is supposed to do is, suppose A contains 20 and B contains 30. I am going to do the exchange in another function called swap. The value of A is going to get copied into X. The value of B is going to be copied into Y. So that's why if you see, the values of A and B are in X and Y respectively. So if you see here, the address of A, I am assuming it to be 1000, B to be 1004, X to be 2000, and Y to be 2004. So this function swap does not return any value. That's why I have declared it as void. It accepts two arguments or parameters of the type integers and integers. So I have declared A and B of type int in main. So first I'm asking the user enter two numbers. So I'm reading 20 and 30 into A and B respectively. Then what I am doing is, before calling this swap function, passing the values of A and B, I am printing the values of A and B in function main. So when I print the values of A and B, I expect it to print 20 and 30 because those are the values I have really entered. So let us say it prints 20 and it prints 30. That's what this statement is doing. Now what I am doing is I am calling swap A comma B. Now let's see what this swap A comma B involves or what it's really expected to do. When I say swap A comma B, the value of A should be copied to X, the value of B gets copied to Y. But as I told you, A and B are different memory locations, X and Y are completely different memory locations. So here what I have done is I have taken a third variable called as temp. We'll not bother about its address. So using the logic which we frequently use, I am exchanging the value of X and Y. So what happens here is X will now become 30 and Y will now become 20 using this particular logic. Now, just to show that X and Y are two different memory locations or different variables, when I come back and I print the value of A and B, it is still going to print the value of A as 20 and B as 30 because when they were copied into a different memory location. So what really happened was we passed only the values of A and the value of B into X and Y respectively. Since X and Y represent different memory locations, any change I make to X and Y will not get reflected here because X and Y are local to swap. They have a scope only within this. Anything you do to temp X and Y has no effect here. So since A, B, X and Y are different memory locations, when I come back and I print A and B, it's still going to print the value of A and 20 and B as 30. So this is known as passing parameters by value. Let's try to understand what this passing parameters by value really implies. Now, when you pass the value, okay, or you call by value, what is really happening is a copy of the data, a copy of A and copy of B is sent into X and Y respectively. Okay. Next, the called function, that is swap, will use the value of A which happened to be 20 and the value of B which happened to be 30. Okay. Those are the values of the actual parameters which got copied into formal parameters, and the program was, or the function was executed using those particular values. Now, the formal parameters are processed. You did the exchange, okay, to do the required work. But these changes in X and Y will not affect the value of A and B or the original values or the actual parameters because A and B represent a different memory location, X and Y represent a different memory location. So if you consider this code example, you will understand that A and B are actual parameters, these are formal parameters. So in simple words, any change to formal parameters has no effect on the actual parameters because both of them represent different memory locations. So this is a concept called as pass by value. Now let us try to understand another thing called as passing constant arguments. I'll just give you an idea. It's not really important at this stage of your career. For example, I can state in the prototype declaration that some of my parameters like this particular p or x or y are constant. So when I declare in the definition as well as in the prototype that x and y are constant and not variables, when I come to the function called as total, I cannot change the value of x and y. The compiler does not allow you to modify the arguments marked as constant. This is very frequently used when you are building user defined or library functions, because when you're sending the actual values, you want to see that they are not changed in this particular function, they're just used as they are. This will be more useful when you work on something called as pointers. When you pass something called as data with pointers, it allows you to change it in the called function. But by making it constant, you cannot change the content of that particular memory location. This is possible because of the const char keyword. So what the const does is it says whatever the values p is referring to, it can be your name, character, anything, it cannot be modified by the person who is implemented this string length. And it makes sense. Suppose you want to find the length of your name, you're sending the name to this function called string length. You don't want your original name to be changed or modified, you just want the string length function to count the number of characters. So in order to solve this particular problem, I am just sending const char your name. So this indicates that your name is not going to be modified or touched in any way except that it's going to be used for counting the number of characters.